All right, so let's talk about how did the big data evolve, right? So if you really think before 2000, when we didn't had a lot of huge amount of the data, I would say the internet was not explored, right? We didn't had a lot of smartphones, we didn't had a lot of so really, if you see the amount of the data which has grown, it has grown in the last 10 years or maybe last 15 years, right? So before that, we didn't have the problem is like with the smartphone coming into the picture, and then the amount of the data which is coming out from the smartphone is kind of the highest, which it has never come out of from any other thing. And then there are components like cloud computing and all the sensors, right? So all the sensors nowadays sending the data, and we are talking about connected world and internet of the things. So as more and more we are getting connected, we are we are generating lot and lot of the data. So after 2000, if you really see, so earlier before 2000, it was like, okay, whatever problem we have, we used to have some database, store the data, and then just just be satisfactory with the database. So database was kind of something which was solving all the business related problem, right? You store your data in some database, and then you run some computation, reporting, whatever we want, right? And then once the data volume increased, so we all the there was a concept of like tera data coming into the picture, right? So like mostly in this range we were having talking when we had terabytes of the data, so we got the components like teradata, exadata, netiza, right? So all of those components is like they gave us some ability to process terabytes of the data, that also faster, right? So that's kind of a bigger computer which will having a larger memory and faster processors. Now, once the data volume even crossed those type of range, when it went to the petabyte range, even these components, they say no, we cannot do that. If you want that, so this solution was not at all cost effective. Right? If some of you are from the Tera data and Exadata, if you are from that background, you would know like if we have to process some petabytes of the data, this kind of servers are going to be very, very costly, right? And the business were not at all convinced with spending so much amount of on these solutions. And what was the next? So the next was something which is kind of a cost-effective solution for large amount of the data, and that's nothing but the Hadoop, right? So thus, if you really look into this, from the smaller database, we went to a larger database, and when we scaled it out a little bit, we thought like we cannot keep on increasing the capacity of the server, right? We have to scale out the server. So we cannot make a one server or five server which is having petabyte of the processing capability. Those type of server will be very, very expensive, right? So what is the solution? We have to scale out the servers. We have to scale out the problem into smaller units and then think of divide and the conquer. So the entire Hadoop concept is based on the concept of divide and conquer. We are dividing this bigger problem into small units, and then we are conquering them in parallel. So let's talk about, there are some of the examples which say like how the data explosion has happened. So if you really see, there are terabytes and terabytes of the data, and there are petabytes and petabytes of data which is getting generated. And these are some of the examples. Like every second, Google is having 40,000 search queries, 300 hours of the video uploaded to the YouTube every minute, right? And if you really see, like 31 million of the messages sent, and 2 million, almost 3 million of the videos viewed by the Facebook users. So all of these things, once the social media is evolving, and once the data is coming out of the gadgets, there is completely no control on the amount of the data which you can have. And if we have to deal with it, assume 31 million of the messages sent, right, by the Facebook user, and that happens almost every minute, every hour, and this has to be stored forever, right? We don't see like Facebook deleted our messages. we see the message which is stored since last 5 years, right? 10 years. So just assume how much of the data would be required and how much of the capacity all these things have to have, like Google, Facebook. All of these are the big giants and they cannot survive unless they have a solution for the big data. They deal with petabytes and petabytes of the data every day. So what's the solution which they are going with? That's what we're going to learn. And the solution is very simple. If one person cannot deal with a larger problem, we have to think of a distributed system, right? So let's say I have I have 10 computers, okay? All of them are not that powerful, but I have 10 in the number. So if I have a larger number of the computers, I have the advantage of using their capability in parallel. And if I can do that, so I have an ability to break down the problem. So that's what is Hadoop based on. Instead of thinking of a very large computer, just think of a distributed small computers. And once they all work in parallel, they you can use their combined capacity to process or to break or to get advantage of the parallel processing and then have that as a solution to the big data problem. Okay. All right. So how does the distributed system work, right? So what mostly we need to do is we have to combine the power of multiple system altogether. Now, what does a computer have? So a computer will have some sort of storage, right? It will have some storage, it will have some processing power, right? It will have some RAM, it will have some CPU, and it will be processing the data. So if we can combine a lot of computers together, what we'll be getting is a engine which has a lot of computation power, which has a lot of storage, and which has a lot of CPU, right? A lot of RAM. So if we can combine the power of a lot of computers, we will be making a very powerful engine, and that's what Hadoop is based on. The Hadoop says don't rely on a single big giant, rather focus on building some or just grouping all the small computing units together and make it a cluster of the nodes which will be having a capacity to store huge amount of the data as well as it will have the capacity to process them, right? And once we have both of these, so that's what the solution of a big data problem is. So big data, the major problem is you have a lot of the data and you want to store them forever and going forward and keep on increasing it. The second thing is you want to process the data also quickly, right? So that all both the problems like storage as well as the computation, it can be solved if we group all the computation power all together. So before we go to the challenges, any questions over here? Like, does it make sense? Like, if we make a lot of computers work together, what do you think? Like, will it solve all the problem or it will have some challenges?
Yeah, I have a question like in through this distributed system, we are using multiple machine for a single job. So here how they can interact to each other for a single job means like
Very
hello.
good. Very good. I'm getting your question. Yeah, that's a very good. It's a great question. So, how will they interact with each other in order to process a job, right?
Sorry, Dheeraj, uh,
All right. So, I got your question. Your question is how will different computers interact with each other to solve a problem? Now, the solution is like all these computers will be connected. Okay, it's simple. Like if you have an organization, like you work in for some IT company. So in your project, let's say there are 100 team members who are working. Now all of them are working to deliver a project. But how are they communicating to each other and how are they delivering the same goal? How it works? So we have a hierarchy, right? So we will be the entire team. There will be kind of a team lead or kind of a project lead who is driving this project, right? And the project members have to function according to how your project manager is saying, right? So that's how the even this process works. So first thing is all of them are connected. The way all the resources in a project are connected, right? All the team members are connected with each other. They communicate with each other. They talk to each other, right? If there's a problem, they go for a meeting and they get the solution and all, right? So first thing is there has to be continuous communication among all the workers, which is definitely we have to build the communication among all the computers, right? So they can interact with each other, they can talk to each other. And second thing is what has to be done, right? If we have to deliver a project, we should know what has to be done, and we need to break down the project into small pieces, right? So starting from requirement analysis, you perform some design, and then you do the development, and then you do the testing, you do the build, you do the deployment, right? So there is what has to be done has to be guided by a plan which is built by some manager or the lead who is driving the entire project. So the similar thing in the Hadoop also, the entire plan for a problem will be built, and then who has to do what, that will be given to all this worker. The worker will be doing their task, and once you consolidate all of that, that's kind of delivering your project. Okay.
Okay, so if one of the machine, for as you said, like it's following some hierarchy,
Hmm.
it will follow as some hierarchy. So if one of the machine is disconnected or if one of the machine is stopped, then what would be the impact? Means it will stop all the processing, all the job, or what happen?
Very good, excellent, super, outstanding question. So that what brings us to the next slide, which talks about the challenges of a distributed system.